Hello and welcome to this fourth video on number system. Here I'll discuss the concept of remainder. We'll learn what is a negative remainder. We'll also look at few properties of remainders with respect to addition and multiplication. We will also learn a very important question type that scares a lot of people in aptitude exams. I am sure by the end of this video you will feel very confident in attacking remainder questions. So let's get started. First, I would like to take a simple example to illustrate what remainder is, and I think this is something we touched upon earlier as well. So let's say you have a number 46, and if let's say I want to divide this number by let's say 4, so I can say 4 into 11 is 44, and if you subtract it you get 2. So ultimately if you see, 4 in this case is what? It is your divisor by which you are dividing. 11 is your quotient and 2 is here your remainder, and this is what we are interested in in today's video, which is 2, right, which is your remainder. So now that means I can write this number which is 46 here, n, right? I can write n in the form of n equals to dq plus r, isn't it? I can, if I were to write this n in the form of r, I can say n equals to dq plus r, right? Now let's take a simple example of a few numbers, right? So let's say you have 311, and let's say you are dividing it by 3. So 3 into 1 3, and 3 into 3 9, right? So how much do you get? You get your 309, and your remainder is 2. That means this 2 is nothing but your positive remainder, isn't it, right? Now what if in this problem you had to divide, let's say 311, you could have also done it like 3 into 1 3, and you can say 3 into 104, and that gives you 312. That means now what you're doing is you are taking one multiple ahead, and you're saying 104 into 3 is 312, and you can say now you get -1. So I know that a lot of you may not be familiar with this, but this is what I want to introduce you to, the negative remainder. That means here, while the remainder is 2, when you took one multiple less and you said if I subtract it you get 2, here you took one multiple ahead and what you got is -1. But one property that you will see, so negative remainder is nothing but -1. But in exams, what we always do is, in exams we always deal with a positive remainder. That means even if you come up with a negative remainder, what you can do is you can always say that the modulus of positive remainder plus the modulus of negative remainder would always be equal to your divisor. In this case our divisor was 3, right? So let's check if this is true or not. Positive remainder was 2 and your negative remainder modulus would be 1. That means this would always be true. So this is the concept of negative remainder. Okay, now let's look at a few more properties of remainder. Now in the case of addition, so let's say if you have a number like, let's say 12 plus 14, and if you were to divide this by 11, right? So what you can do is you can obviously say this is 26 upon 11, and you can say 11 into 2 22. So your remainder is how much? 4 is your remainder in this case, isn't it? But what you could have also done is you could have said I will take the remainder here separately and take this remainder separately, and I could have added the same. That means that property is also valid in with respect to remainder. So for example, if let's say 12 by 11, you get a remainder here 1, isn't it? And here you get a remainder 3. So you could have done 1 plus 3 4, and that was the remainder. That means in case of remainders, in case of addition, you can say your final remainder would be addition of the remainders that are coming, right? And so on, right? If there are 3 or more as per the case. Now let's look at the case of multiplication. So let's say you have 7 into 8 upon, let's say you have 6. That means what? That means if in a normal scenario what you would do, you would say 7 into 8 is 56. So 56 upon 6. So what you'll do, 6 into 9 9 6 54. so your remainder is 2, right? But instead of multiplying and then dividing it by 6, what you could have done is you could have said, I will take this separately, and all I could do is I would just multiply. So here your remainder would be 1 and here would be R2. So multiplication property is also valid here. So for example, 6, 7, what is the remainder here? You will get 1. What is the remainder here? You get 2. So ultimately 1 into 2, 2 is the remainder. So that means in case of multiplication, your final remainder would be R1 into R2. Now this is a very helpful property and we will look at a few questions so that you understand what I'm saying. Okay. All right. So now it says what is the remainder in this? That means if this big number 2301 into 2304 into 2307 upon 2299. In the previous case, it was easy to multiply because the numbers were very small. But imagine a scenario like this. So obviously examination setter is not expecting you to multiply this, right? We wouldn't want to make that mistake. That means here what you could do is you can say whatever the remainder I get here, let's say R1, and with this one if I get, let's say, R2, and if this one if I get R3, I'll just multiply that and I'll get my answer. So what we'll do in this case, in the first R1 would be how much? This is 2, right? 2301 upon 2299, that means this would be 2 into, here would be 5 into 2299 2307, meaning this is 8. So your answer would be what? This is 2 into 5, 10, 10 into 8, 80. So this is extremely easy. But imagine if you did not know this property of remainders, it would have taken a lot of time. Okay, let's look at another problem. This says 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial up till 19 factorial. What is the remainder when this whole thing is divided by 24? Okay, imagine. So obviously it is not practical to multiply and see what is the value of 19 factorial. This is going to be huge and then see what is the remainder. So again, what we'll do here, this is all addition. That means we will use the property of addition, with respect to in remainders. So here if you look closely, your 1 factorial would be 1, your 2 factorial would be 2, your 3 factorial is 6, right? Because 3 into 2 6. Your 4 factorial is 24. Now see here, that means your 4 factorial is 24, then it is 120, and then of course 720 and so on and so on. But importantly, any after 4 factorial or even 4 factorial, for 4 factorial 24 upon 24 remainder would be 0. That means here the remainder would be 0, and going forward ahead up till the 19th factorial, everywhere your remainder is going to be 0. So that means we have to check only for these three numbers. Now that was the only observation that was required. That means 1 plus 2 plus 6 plus everything is 0. So no problem upon 24. We just had to check here. That means 6 plus 2, 8 plus 1, 9. That means 9 upon 24. So obviously what is our remainder in this case? 9. This was extremely easy, but it required some observation. So instead of getting scared after looking at factorials, you just have to figure out what is the logic here. Okay. So now that you've understood a few properties of remainders, let's discuss one problem type which you will see in the exam. That means sometimes in the exam they will say a to the power n is divided by b. So you have to tell them what is going to be the remainder. Now let me take a few examples. So let's say you have a number like 3 to the power 44 upon 10. So they're saying when 3 to the power 44 this is divided by 10, what is going to be the remainder? Now what you do in these problems is you try to write 3 in such a form that is plus minus 1 of this number 10 of the divisor. That means I can write 3 to the power 44, I can say 3 to the power 2 to the power 44. Would you agree with me? So what we are trying to do is we are trying to write this 3 in the form of 10. That means plus minus 1, 10 plus 1 or 10 minus 1. Now 10 plus 1 is not possible, but 10 minus 1 is possible because 3 to the power 2 is 9. Sorry, this would not be 44. This would be 44 by 2, right? Or you can say this is 3 to the power 9. That means 9 to the power 22 upon 10. Now I can also write this number as 10 minus 1 to the power 22. I can write 9 as 10 minus 1 to the power 22 upon 10. Now if you were to divide this, right, this would always be 0. That means only this one would remain, right, minus 1. So this one would be, your remainder here would be minus 1 to the power 22. The reason why we represent this number, let's say a in the form of bm plus minus 1, so that this 1 to the power whatever, if there is 1, it is easy to find out, whether it is 22 or 200, 22 or 2000 also, it's easy to find out because it will always remain 1. So here would be minus 1 remainder to the power 22, that means positive remainder, it will be 1 only, right, because this to the power even power. So this is your 1 as your answer. Okay, so now let's look at another problem. Okay, let's say in this case you have let's say 2 to the power 22 upon, let's say, 5. Now this is simple. I can write this 2 in the form of 5 plus minus 1. That means 2 to the power 2 is 4. So that means that I can write that 4 as 5 minus 1. So what I'll do is I'll say 2 to the power 2 to the power 11 upon 5, isn't it? 2 into 11, 22. This is what it is. Now this can also be represented as 2 to the power 2 is 4. That means this is 5 minus 1 to the power 11 divided by 5. So obviously this is easy to find out. This would always be 0. So minus 1 to the power 11. That means your remainder would be minus 1. Now if your remainder is minus 1, so like I said, minus 1 is not considered in the exam. So what you'll do is you'll do minus 1 plus what should you add so that this becomes 5, right? That means your remainder in this case would be 4. Okay, now let's solve a few questions for practice. So 2 to the power 24 by 3. Now 3, okay, so this is already in the form of 2 to the power 24. So what you can do, either you can do 2 to the power 2, right, or this is already in this format, right? That means I can say, if you have to divide this by 3, you can say this is 3 minus 1, right? That is what 2 is, to the power 24 upon 3, right? Isn't it? This 2 can be written in this format also. That means now I can say this would always be 0. So minus 1 to the power even number. That means your remainder would be 1. So this is pretty simple. Okay, now you have 17. Okay, but nothing to get scared, because 17 is also of the form 18 minus 1. So you could have done this as, this is nothing but 18 minus 1 to the power 41 upon 18. Now this would always be 0, but with minus 1 to the power 41. This is how many times? This is odd number of times. That means your remainder is going to be minus 1. Minus 1 remainder meaning, minus 1 remainder meaning we have to subtract this from 18. So that means answer would be 17, because we don't consider the negative remainders. Okay. Now this is the last problem, but it has an important concept here. So 2 to the power 101 divided by 34. Now if you actually attempt this question, you will see 2 to the power 101 upon 34. Now any power of 2, let's say 2 to the power 5 is 32, and then you have 64, but it is not in the form of plus minus 1. It's not easy to find plus minus 1 form. That means what I can do is, but that 17 into 2 is 34, and I know 17 is closer to your 16. That means if I can write this as 2 to the power 100 into 2 upon this, I can write as 17 into 2, isn't it, right? I've just expanded it, right? So this 2 gets cancelled. Now remember, what you're doing is you are making the divisor from 34 to 70. That means you're dividing it by 2. So just remember this, because we will have to multiply the same in the final answer in the remainder, right? So that means now what you effectively get is, you get 2 to the power 4, right, to the power, this is 2 to the power 4 to the power, now this would be 25 upon 17. This is what you have to do. And 2 to the power 4 can be written as your 17 minus 1, right? This can be written as 17 minus 1 to the power 25 upon 17, right? Now of course 17 gets cut. This is easy. All you get is minus 1 to the power 25. That means your remainder is minus 1. But if you remember, what we had done is we had divided by 2. That means you will multiply now by 2. So your remainder is actually minus 2. And because we do not consider the minus 2 remainder, what we will do is we will add this in 34. So your answer would be 32. Okay. So if you notice, I multiplied this by 2 because we had divided. If you don't want to do this and with -1 only, if you want to play, what you could have done is you can say -1 of 17. So you could have said, okay, this would be 16 remainder, right? Here only. But then eventually you will have to multiply it by 2 because you divided here by 2. This is what you did, right? So answer would be 32. So I hope you now have good understanding of remainders and you're confident in attacking problems on remainders. So thank you, and I look forward to seeing you in the next video.